Okay, so today we are going to start series. Okay. So first we discuss about series with positive terms, and then we discuss series with the negative terms. So first, infinite series with the positive terms. Okay. So suppose we have a okay, we can write the topic series with the positive terms. Okay, suppose we have a sequence un. So given any sequence, we form a infinite series. Suppose an is a sequence. So given any sequence an, we can form a series. It's nothing but just to add all the sequence terms, that is a1 plus a2 plus etc plus an etc. So if you add all the terms of the sequence, we say this is an infinite series. So this is actually infinite series. Now the natural question is, what is the value of this sum? If it is exist or not. Okay. Okay. So another way of writing this summation is simply write summation an, where n equal to 1 to infinity, or simply we can write just summation an. Okay. Okay. So similarly, so now given any sequence, we can form a series, just all the terms. Now suppose given series, we can form a sequence. Okay. Suppose summation un is given. Summation un is a series is given, where n equal to 1 to infinity. Now we form a sequence. So the sequence, the first term, we take u1. The second term of the sequence, we take u1 plus u2. And so on. The nth term of the sequence, we define u1 plus u2 plus etc. plus un. Okay. Now, these Sns are called partial sums. Okay. This S1, S2, etc. Xn are called partial sums of the series. So the sequence now we get, and so on is going on. Now we get a new sequence, that is Sn. This sequence, okay. The sequence Sn is called partial sums. The sequence Sn is said to be a sequence of partial sum. A sequence of partial sums of the series. Partial sums of the series un. Of the series summation un. Now, if the sequence Sn is converges, because already we discussed about convergence of the sequence. Suppose if the partial sum converges, then the series converges. So that is, suppose if the limit n goes to infinity, the partial sum Sn, suppose is converges to some point S, then S is called as sum of the series. Then the point S, then S is called the sum of the series. Sum of the series un. Okay. And we write the sum value is S, and we write S is nothing but summation of un n equal to 1 to infinity. Okay. Now we say a series is convergence if the partial sum is converges. If the partial sum is converges, then we say the series is converges. Otherwise, the series is diverges. Okay. So the infinite series infinite series un is said to be convergent, summation un is convergent, is said to be convergent, is said to be convergent if the partial sum, the sequence, if the sequence Sn of partial sums converges, is convergent. And then the value is nothing but the limit of the sequence Sn is a sum. So suppose when we say the sequence is divergence, so the series is said to be divergent. The series summation un is said to be divergent if the sequence Sn is divergent sequence or not convergence. Okay, if the sequence Sn of partial sums is divergent, if the sequence of partial sums, maybe I can call that sequence is maybe Sn. The sequence Sn of partial sums of the series un is divergent, then the series is divergent. So again, when this series is said to be oscillate, the corresponding sequence of partial sum is oscillates. So the series summation un is said to be oscillate, is said to be oscillate if Sn is oscillate sequence. Okay. So now in this session we are going to check whether the given series is convergent or not. Okay, there are some theorems are there. So first we discuss some examples and then we move to the theorems. Suppose first example, if you consider the series summation n equal to 1 to infinity 1 by n into n plus 1. So that is what is the explanation. If you substitute values n equal to 1 to, if substitute n equal to 1, we get 1 into 2 plus 1 by 2 into 3 plus and so on. So the nth term is 1 by n into n plus 1 and so on. So this is a series. Now if it is converges, what is the value of this sum? So first we have to split this function using the partial fraction. We can directly write 1 by n minus 1 by n plus 1, because if you just cross multiply and then simplify, you will get a 1 by n into n plus 1. Okay. Now, so therefore this is nothing but this value. So that is, therefore what you get? So what is S1? You have to check the partial sum converges or not. So what is S1? S1 is nothing but U1. So U1 is nothing but you have to substitute n equal to 1. Therefore, if you get 1 by 1 minus 1 by 2, that is 1 minus 1 by 2, that is U1. What is S2? S2 is nothing but U1 plus U2. So that is U1 is 1 minus 1 by 2 plus U2 is 1 by 2 minus 1 by 3. Now 1 by 2 cancel, we get 1 minus 1 by 3. So therefore S2 means 1 minus 1 by 3. If you take S3 is U1 plus U2 plus U3. Actually this is UN. Okay. So therefore, sum of first three terms, therefore u1 is 1 minus 1 by 2 plus u2 is 1 by 2 minus 1 by 3 plus u3 is 1 by 3 minus 1 by 4. Now 1 by 2, 1 by 3 cancel, we get 1 minus 1 by 4 and so on. In general, the nth term of the sequence Sn can directly write 1 minus 1 by n plus 1. Okay. Now this is a sequence Sn. Now what is the nth term of the sequence is 1 minus 1 by n plus 1. As n goes to infinity, this sequence converges to 1 because this converges to 0 is a constant sequence converges to 1. Therefore, this partial sums converges to 1 as n goes to infinity. Therefore, the partial sum converges. Therefore, the series is converges. The sum of the series is 1. Therefore, sum 1 by n into n plus 1, the value is 1, where n equal to 1 to infinity. This converges, maybe I can write, it converges, convergent, and its value is, and its sum is 1. Okay. Now we discuss another example. If we take n square, that is sum of n square, where n equal to 1 to infinity. So actually, if we expand this, we get 1 square plus 2 square plus 3 square and so on. Plus the nth term is n square and so on. This is a series. Now we have to find the partial sum. So what is Sn? Sn is u1 plus u2 plus etc. plus un. So what is u1? Just 1 square. What is u2? 2 square and so on. What is un? N square. We know that the square of first n natural number sum is n into n plus 1 into 2n plus 1 by 6. Right? Now, as n goes to infinity, this series diverges. The sequence Sn diverges to infinity or diverges to. It's a divergent sequence because as n goes to infinity, the numerator we have a n. Therefore, this Sn is diverges. The sequence Sn, the partial sum is divergent. Since the partial sum is divergent, the given series is divergent. Therefore, the summation is n square is divergent sequence. Now, if we take the third example, suppose consider the series minus 1 power n, where n equal to 1 to infinity. So that means what? Minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 and so on. So this is series. Now what is the Sn? So Sn is, there are two values depending upon, so what is S1? So S1 is nothing but just U1. So S1 is U1, U1 is nothing but just minus 1. What is S2? S2 is U1 plus U2. So U1 is minus 1, U2 is 1, therefore we get 0. And S3 is you will get minus 1. S4 is you will get 0. Okay. So in general, the Sn is minus 1 if the n is odd, 0 if n is even. So this is the oscillate sequence between minus 1 and plus 1. So clearly, therefore, Sn is oscillates. Correct? Therefore, the given series is oscillate. Hence, the series sequence Sn is oscillates. Since this is oscillates, therefore, the given series is oscillate sequence. We cannot say it's a divergent series, but it's oscillate sequence. Oscillate or oscillatory series n equal to 1. Now we have some theorem. There is some necessary condition that a series is convergent. So first, given any series, first you have to check that the nth term goes to 0 or not. Okay? That is a necessary, not sufficient, a necessary condition for convergent. Maybe I state the theorem, maybe I can write. Suppose if the series is convergence, if the series summation n equal to 1 to infinity un converges. Suppose this series is converges, then the nth term of the series is converges to 0. Okay, suppose the nth term is not converges to 0, then the series is not convergent, because convergence means the nth term should converges to 0. Okay, so this is very important result. But the converse need not be true. Suppose the nth term is converges to 0, we can may or may not be the series is converges. Okay, I will give the example, that is 1 by n. So first we discuss some example of.
Sir, not in every case the nth term will be converging to 0.
If it is converges, if the series is converges, then the nth term must converge to 0. If the nth term converges 0, we cannot say the series
in the
is.
last example also, the nth term was convergent to 1, no, sir?
No, that is partial sequence, not series. So, okay, so that way we get this sequence. So nth term is, look at this. This 1 by n into n plus 1. This is the nth term.
Yes. So that will be converging to 0.
Yeah.
This is convergence rate. Okay.
Yeah. So don't confuse this partial sums and then that's nth term of the series.
Okay.
Okay, that is different. That the nth term of series is different. Nth term of this partial sum is different. So if the nth term of the series, if the series converges, the nth term is converges 0. So otherwise, if the nth term is not converges to 0, then the series is diverges. Okay? Because usually saying P implies Q, the statement P implies Q, same as not Q implies not P. Okay, so this is a statement. Suppose some statement implies another statement is same as that not of the other this statement conclusion implies not of the assumption P. Both are equivalent. Okay, so now we have discuss some examples. So the converse may not be true. Why we discuss some example. Suppose so the converse may not be true. The converse of the theorem. Converse may not be true. So that is the nth term converges 0, but the series diverges. What is the example? Suppose if you take the nth term or the series summation un is summation 1 by square root of n, where n equal to 1 to infinity. So what is the series? Substitute n equal to 1, 1, substitute n equal to, we get 1 by root 2 plus 1 by root 3 and so on. So clearly the nth term is 1 by root n, that is converges to 0. 1 by square root of n, as n goes to infinity, this converges to 0. But the series is not convergent. Why the series is not convergent? If you find the partial sum, so what is partial sums? Sn, the nth term is sum of first n terms. That is 1 by 1 plus 1 by root 2 plus 1 by root 3 and so on. Okay. Now, the final one is 1 by square root of n. This is the nth partial sum of the nth term of partial sequence. Now, what is the relation? So, n is here fixed. Okay. So, what is the relation between the square root of 2 and then square root of n? Square root of 2 is less than or equal to square root of n. Therefore, 1 by square root of n is less than or equal to 1 by square root of 2. Or if you take any number, if you take square root of 3, that also less than or equal to square root of 3. So therefore, each number is always bigger than square root of n. 1 by square root of n. The 1 by square root of 2 also greater than 1 by square root of n, and so on, plus 1 by square root of n. So this will get n times square root of n. So this is equal to n by square root of n. But n can be written as square root of n into square root of n. We can cancel one square root. Therefore, we get square root of n. Therefore, this Sn is bigger than square root of n or any n. So therefore this Sn may not converge because we know that every convergence sequence is bounded. If it is the partial sum is converges, it should be bounded. But here we prove that the Sn is bigger than square root of n if you take any n. Therefore the sequence Sn is not bounded. There is no bounded and there is no upper bound for this case. So therefore since Sn is not bounded above or not bounded, implies Sn is not converges. Sn is diverges. Because if it is converges, should be bounded. If it is not bounded, definitely should be diverges. Maybe diverges to plus infinity or diverges to minus infinity, but everything here positive, therefore diverges to plus infinity. Since the partial sum is diverges, therefore the given series is diverges. Therefore summation 1 by square root of n is divergent. But the nth term is goes to 0, but the series not converges. Therefore the converse may not be true in general. But if the series is converges, then definitely the nth term converges to 0. If the nth term not converges to 0, then series is not converges. Okay, we discuss some example. Show that the series is convergent. Okay, show that the series, what is the series? Square root of 1 by 4 plus square root of 2 by 6 plus etc. I am writing the nth term square root of n by 2 times n plus 1 and so on. Okay, this is a series. You have to say that does not converges. Show that this series is does not converges. So what is the nth term? Un is square root of n by n into n plus 1. So square root of n by, if you take n outside, therefore 2 times n into 1 plus 1 by n. Now we can cancel n, we get square root of 1 by 2 times 1 plus 1 by n. As n goes to infinity, this un goes to what? This is goes to 0 and this is 1. Therefore this is 2. Therefore square root of 1 by 2. Since the nth term is not converges to 0, definitely the series is diverges. That is not convergence. Therefore summation un is divergent. So if the nth term is not converges to 0, we can say is divergent. If the nth term converges to 0, we cannot say about the convergence of the series. But if the series is converges, then the nth term is converges to 0. Okay. So given any series, first you have to take the nth term and then you have to check that it goes to 0 or not. If not goes to 0, then you can conclude that the given series is not convergent. If it is converges to 0, we cannot say anything. We have to apply some test to check whether the series is converges or not. Okay. Now I ask one more question. Okay. Now third problem. Okay. Next problem. Exercise. So what can you say about the series summation cos of 1 by n square, where n equal to 1 to infinity? Is this series converges or not? So what is the nth term? Un is cos of 1 by n square. So what can you say about as n goes to infinity, where this goes to? Since 1 by n square is converges to 0. Okay. So since cos x is a continuous function, you will study later. So suppose a sequence xn converges to x and f is continuous function, f is continuous, then f of x and converges to f of x. Okay, provided f is continuous. Since cos x is a continuous function and 1 by n square converges 0, therefore cos of 1 by n square converges to cos of 0. And we know that cos 0 value is 1. Okay, so nth term converges to 1. This is not equal to 0. Since the nth term is not converges to 0, the given series is divergent. Okay. Maybe there are some more examples there. Now I ask one more question and then we move to the next one. So exercise, check the series converges or not. The nth term is n square minus 1 by n square plus 1 as n equal to 1 to infinity. What can you say about the series? Is converges or divergent? And then the next problem is n by square root of n by n plus 1, n equal to 1 to infinity. Okay, now tell me, what is the first one? What is un? In the first problem, un is?
First one converges, sir.
Why?
So we can take n square outside.
Yeah, if we take n square outside and cancel, we get 1 minus 1 by n square by 1 plus 1 by n square. As n goes to 0 or at n goes to infinity, this goes to where? 1 by n square is 0. 1 is not equal to 0. Therefore, it diverges. Now, what about the second one? Is converges or not? Where this converges? This yes, un is converges to take n outside and then cancel and then apply n goes to infinity. What will happen? What is the limit? 1. Again 1. Because square root of 1 by 1 plus 1 by n as n goes to infinity. So we'll get a square root of, if we cancel n, we get this. So at n goes to infinity, this goes to 0. Therefore, square root of 1 by 1 is nothing but 1. Since the nth term is not converges to 0, the given series is diverges. Okay. So this is a very important thing. So this is a necessary condition that a sequence is convergent, not sufficient. Now, suppose the series is convergent, then it should be bounded. The partial sum is bounded, right? Because if the partial sum is convergent, the series is convergent. If the series is convergent, the partial sum is convergent. Partial sum convergence means what? Every convergent sequence is a bounded sequence. Okay, therefore, we can say the partial sum is bounded, or we can say, so what I'm saying, so suppose summation, the series an, n equal to 1 to infinity, is convergent. Suppose it's convergent, implies the partial sum Sn is converges. Because it is convergence, then only we can say it's a convergence, right? So it's a convergence, therefore, every convergence sequence is bounded sequence, therefore, the un is bounded. And even more, and we know that it's every convergence sequence in a real case is a Cauchy sequence, right? So therefore, Sn is also Cauchy. So Sn Cauchy means what? After certain stage, this Sn minus Fsum is less than epsilon whenever n comma m greater than or equal to some stage n naught. Suppose assume that n is bigger than m. So therefore, what is Sn? Sn nothing but u1 plus u2 plus etc. plus un. And what is Sm? Up to m. So Sm is u1 plus u2 plus etc. plus un. Now what is Sn minus Sm? So m is smaller. Therefore, u1, u2 up to u means cancel. We get um plus 1 plus um plus 2 up to un. The modulus of this is less than epsilon, therefore modulus of this is less than epsilon. So if, sorry, I am taking A1, so for everything change into A1. Okay. So if the series is converges, then the partial sum is Cauchy sequence. Because it converges, therefore it's a Cauchy sequence, and then satisfy that this relation whenever for every m greater than or equal to that n naught stage. Now, and then the important series is, that is harmonic series, summation 1 by n. It's a very important thing. Summation 1 by n, where n equal to 1 to infinity. If you consider this series, actually this series is called harmonic series, okay? This is harmonic series, summation 1 by n. So that means what? That is 1 plus 1 by 2 plus 1 by 3 and so on. The nth term is 1 by n and so on. But here the nth term is goes to 0, but the series is not convergent. This is another example. This is another standard example that the nth term of the series is converges to 0, but the series is not converges. Because 1 by n converges to 0. The nth term is 1 by n is converges to 0, but the series is divergent. Why the series is divergent? If you take the partial sum, what is Sn? Sn is nothing but 1 plus 1 by 2 plus etc. up to plus 1 by n. This is a partial sum. Okay, now, and by previous result, if it is, suppose assume that the series is convergent, then this is happen. After certain stage, this sequence terms, if you add the series terms, it should be less than epsilon for any epsilon, right? So better I am taking Sm plus 1, that is, if it is so, we have to prove that this is divergent. Suppose is convergent, then the partial sequence is convergent. This means it's Cauchy sequence. Therefore, modulus of Sn minus or Sm minus Sn. Assume that m is bigger than n. Okay. Now, if you subtract this, you will get 1 by, or we take better we take the same thing. Sn. This is Sm. So n is bigger than or equal to m. If you subtract this, you will get 1 by m plus 1 plus 1 by m plus 2 plus etc. The last term is 1 by n. So this is less than epsilon for every epsilon, right? Because already we know it's a Cauchy sequence, therefore it's true. The distance between any two sequence terms are very close. So this is true for every epsilon. Suppose I am taking the particular epsilon in, if you take 1 by 4. Okay, so for any m which is greater than or equal to m, so this is true because of Cauchy sequence. Now, if you consider this 1 by m plus 1 plus 1 by m plus 2 and so on, 1 by n, this is equal to, so this is true for every n, right? In particular, I am taking n equal to bigger than m, so I take 2 times m. So therefore, this is true for any n, in particular 2 times m also true. So up to I am adding m plus 1 by m plus 1, 1 by m plus 2, etc. 1 by m plus m, that is 2m. Okay. Now, what is the relation between this m plus 1 and then 2m? So m plus 1 is smaller than 2m because 2m is m plus m. But 1 by 2m is smaller than 1 by m plus 1. Therefore, the first term is bigger than or equal to 1 by 2. So please wait. Okay, so the first term 1 by m plus 1 is bigger than 1 by 2m. Plus the second term also 1 by m plus 2 is bigger than 1 by 2m. So every term is bigger than 1 by 2m. The last term 1 by 2m also greater than or equal to 2m, but we have a strictly. Now how many times we have? We have m times this, right? Therefore, this is equal to m times 1 by 2m is nothing but 1 by 2. Okay, now the difference actually we get a 1 by 2 which is bigger than 1 by 2, but here we get less than 1 by 2, sorry, less than 1 by 4, but here we get greater than 1 by 2, which is a contradiction. Okay, therefore our assumption is wrong. What is our assumption? We assume that the series is convergent and the partial sequence form a Cauchy sequence, then we get a contradiction. Therefore the given sequence series is divergent. This harmonic series is divergent. Okay, it's not convergent. If you suppose such convergent, we get a contradiction. Okay. Now there is some test is there to check the series is converges or not. Okay. Suppose we have a series with positive terms. If it is suppose the partial sequence is bounded above, then it is converges. So in the sequences we studied one result. What the result we studied? Suppose we have an increasing sequence, that is xn is less than or equal to xn is less than or equal to xn plus 1 for any n. So that is we have an increasing sequence. So suppose when this increasing sequence is converges, so that's to some point. When it's increasing but it converges, then what can you say about this xn? Is bounded above by some number, right? Similarly, if it is decreasing and it is converges, if it is bounded below, then it is converges. So if it is increasing and bounded above, then the sequence is converges. Xn converges to x, some x. If it is increasing sequence and bounded above, then it converges. Similarly, for decreasing sequence is bounded below, then it converges to its lower mode. Now same thing here. So that is a theorem. The necessary and sufficient condition for a convergence of a positive terms of sequence. Suppose the summation un n equal to 1 to infinity. Okay, before that, the partial sequence of any series, positive series, is always increasing. Why? Suppose yes, we have a series, we have a positive series, that is UNs are positive, and then we have considered the series summation un where n equal to 1 to infinity. Okay. Now what is Sn? Is nothing but u1 plus u2 plus etc. plus un. What is Sn plus 1? Is u1 plus u2 plus etc. plus un plus un plus 1. Now, which one is smaller, which one is bigger? So if you subtract Sn plus 1 minus Sn, so u1, u2 up to un is cancelled, you get just un plus 1. And we know that all the uns are positive. Therefore, the subtraction Sn plus 1 minus Sn is positive, greater than or equal to 0. Suppose we are taking non-negative, is greater than or equal to 0. So take this Sn to that side, we get Sn is smaller than Sn plus 1 for any n in n. Therefore, the partial sums of any series of positive term is an increasing sequence. Increasing sequence. Now tell me that when the series is converges, theorem. Suppose you have a non-negative numbers. If the series summation un is convergent, if and only if, what can you say about Sn?
Bounded above.
Yeah, is bounded above. Because already we know that is increasing, and I am saying that the series is converges, therefore Sn should be converges. So when it will converges? Only when it's bounded above, because it is increasing. Therefore, if it is bounded above, then Sn is convergent, then only we can say the series is convergent. So it's if and only if. Okay, if suppose Sn is bounded, no need to check Sn is convergent or not. Okay, hereafter, no need to check the partial sum convergent or not. Just check that the partial sum is bounded above or not. When it is bounded above, we can say directly say that the series is convergent. Okay, this is useful there. But provided each UNs are non-negative, that's very important thing. Okay. Suppose we have some test. What is the test? Comparison test. Maybe I may state as a theorem. Suppose we have a series. Suppose we have a un less than or equal to vn for all n in n. Okay, and if this series summation vn is convergent, then the corresponding this series summation un is convergent. Okay, and this is the first case. If this series is convergent, this is the nth term of some series, this is the nth term of some other series. If this series is converges, then this series converges. Okay, but if this series converges, we cannot say about this series. Maybe it converges or diverges. But this series is diverges, then definitely this series also diverges. So that is second part. If summation un is divergent, then summation vn is divergent. If the small series is divergent, then the bigger one is divergent. If the bigger one is convergent, then the smaller one is convergent. This is a comparison test. Okay. Now, okay, this already I said that maybe I asked question. What is the question? Suppose we have a positive terms. Okay. Suppose if summation un is a series of positive terms, is a series of positive terms, and the limit n goes to infinity un is non-zero, then what can you say about the series is what? Divergent. Because if the nth term not converges 0, then automatically the series is divergent. Okay, it diverges. Okay, again now sum of two convergence sequence is convergence, and then limit is sum of the limit. Again, if you take the subtraction of two convergent series is also convergent. Maybe we state as a theorem. Suppose we have a two series, convergent series. Suppose if summation an and summation bn are two convergent series are two convergent series. Okay, then the sum, you have to add term by term, that is a1 plus a1 b1, that is the first term, a2 plus b2 and so on. So therefore this, then the summation an plus bn, and if you take subtraction also, an minus bn are convergent. Okay. So now, suppose one series is convergent, another series is divergent, then what can you say about the sum? The next theorem. Suppose if summation un is convergent, converges, and summation vn is diverges, then what can you say about the sum? Is converges or diverges? Check the nth term converges 0 or not. So this actually diverges. Because since un is convergence sequence, therefore un converges to 0. Okay. So therefore this vn converges some other point x. If you sum this, un plus vn is converges to x. Therefore it's not 0. Therefore diverges. But if you take the special case 1 by n, you can prove it. Otherwise, you can prove this. I take the simple thing, but you can prove that this series is divergence, because if you take the partial sum, you can show that this is not bounded above. Okay. Therefore, in general, sum of convergence sequence and then divergence sequence is diverges. Now, we discuss some examples. Summation n power 1 by n. So exercise. So the series 1 by n whole power 1 by n equal to 1 to infinity. Is this converges or diverges? What is the nth term? un. 1 by n power 1 by n. As n goes to infinity, this goes to where? I already said that 1 by this converges to
1, sir.
1. So since the nth term is not converges to 0, therefore this series is diverges. Okay. So how to prove this one? Otherwise, you can apply L hospital rule to check that the nth term is not converges to 0, or directly we can use this one is diverges. Okay. There are some other way to show that the limit is, anyway, the nth term limit is always 1. So we can use the result n power 1 by n converges to 1. You can use this result to directly we can say this is converges to 1. Otherwise, you can take log and then apply L hospital rule. You get the value is e power 0. Finally, you get 1. Anyway, so this series is divergence series. Now, so here what I am going to show, suppose the series, suppose the partial sum is bounded above, can we say the series is converges? Anyway, the partial sum is convergent, bounded above, but it's not bounded. It's not convergent, but it's bounded above. Can we say the series is converges? Suppose Sn is bounded above. Bounded above of some partial sums, of some series. Can we say summation that series un is convergent? No. If all the uns are positive, then the theorem says if Sn is bounded above, then series is convergent. But if u1s are non-negative, that is both positive and negative, even the Sn is bounded above, but still the series is not convergent. What is the example? If you take the nth term, un is minus 1 power n. Therefore, the Sn, the partial sum is, if you take even, for n even, we get 1. And if n is odd, sorry, for un, not Sn, un is 1 minus 1 if n is odd. So therefore, what is Sn? Sn is nothing but sum of ui's. Again, sum is 1 or 0. When we will get 1 if it is odd, right? If n is odd, we get 1. If n is even, we get the term is 0. Therefore, the Sn partial sequence is 0 and 1, 0 and 1. Anyway, it's bounded above. Even you can say it's a bounded above. The sequence Sn is bounded above by 1. Each Sn is bounded above by 1, therefore bounded above. But it's not convergent. Why? Because all the u's are not non-negative. That's why even the partial sum is bounded above, still the series is diverges. So it's not, sorry, this diverges. Okay. So if if the partial sum is bounded above and each un is non-negative, then the series converges. Otherwise, the series may not be converges. Okay. This is an example. Okay. So for any doubt? Okay. Maybe can stop now. So in the next class, we discuss some more standard examples, and then we solve some problems. Okay. Thank you.